Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
Hello everyone, and welcome to our Swift Interview Questions series. In this lecture, we're going to look at the top categories asked about at the coding interview. And we're going to look at the most popular questions asked by FAANG companies, that is Facebook, Amazon, Netflix, Google, and the likes. So you are going to learn not only the most common questions and how to solve them, but also how to recognize patterns in questions. That way you'll be able to tackle any question that is thrown at you. So let's go ahead and do an overview of the different categories of this course, starting at 1 and we're ending at 10. So first we're going to do an introduction and talk about the Fizzbuzz interview question, one of the most common ones, almost synonymous with the term interview question. Then in section 2, we are going to begin our first category, which is string and array. We're going to look at the array data structure as well as strings and solve some interview questions regarding strings and arrays. This is one of the biggest topics asked about. That's why it is number 1. We're going to solve questions like reversing words in a string, finding isomorphic strings, and finding the kth largest element in an array. And we'll be defining all the terms you need to know, so not to worry about that. Then in section 3, we are going to jump into the matrix data structure. We're going to learn how to use algorithms to solve matrix interview questions, including setting matrix zeros and printing the spiral matrix and the popular number of islands, also known as the number of countries interview question. In section 4, we are going to analyze the linked list data structure. We're going to use algorithms to solve interview questions pertaining to linked lists. This includes implementing the linked list data structure from scratch and implementing a stack using a linked list, questions of that sort. Then in section 5, we are going to look at the binary tree data structure and interview questions pertaining to that. We're going to build algorithms to solve different types of traversal of binary trees, including depth-first traversal, such as in-order traversal, pre-order traversal, and post-order traversal. And we're also going to solve the popular binary tree maximum path sum question. Then moving on to section 6, we are going to look at different sorting algorithms with Swift. We're going to look at sorting algorithms from slowest to efficient, and we will be looking at the time complexity of each of the sorting algorithms that we cover. We're going to cover algorithms like the bubble sort, selection sort, insertion sort, quick sort, merge sort, all of the popular ones you need to know. Then in section 7, we are going to jump into dynamic programming. This is an algorithmic paradigm that you need to know, and we'll be looking at questions where dynamic programming comes into use over and over again in the implementation of algorithms. We're going to solve questions like the popular coin change problem and finding the maximum sum subarray in an array. Then in section 8, we are jumping into bit manipulation. Manipulating bits will allow you to create highly efficient solutions that are even more efficient than iteration or recursion or backtracking or sorting. By manipulating bits and working with bitwise operators, you'll be able to solve questions extremely impressively because your solutions will be concise and time efficient. So we're going to look at the common bitwise operators you need to know and manipulating binary representation of values in section 8. We're going to solve questions like finding the single number, finding the number of 1 bits, also known as the Hamming weight, and finding the sum of 2 integers, all using bitwise operators. By mastering bitwise operators, you will definitely impress the interviewer. So after that, in section 9, we are going to look at combinations and permutations. Extremely important to understand the difference between the two. So we're going to understand these topics which come from math and apply them into interview questions. We're going to solve questions like finding permutations and finding factor combinations, practical examples of some sample questions that you might get on the test and sub-questions of larger questions as well. Then finally, in section 10, we are going to look at math interview questions. Now, math is similar to bit manipulation because it will allow you to provide extremely concise and efficient solutions. Because if you can find a mathematical solution to a problem, it can often be extremely efficient. So we're going to solve questions like reversing an integer, finding the palindrome number, and the popular Excel sheet column number question, and of the sort. And you will learn to recognize the patterns of mathematical questions and how you can use math in different scenarios. And that is everything that we're going to be covering in this course. In order to test all our code, we're going to be using a free online IDE integrated development environment known as repl.it. So just type in repl.it into your browser and you'll be taken to this free website where you can code in up to 50 languages without downloading or installing anything. You don't even have to sign up. You can just click Start Coding and then choose your programming language and click Create REPL, and you'll immediately be taken to an online IDE. And this is extremely useful, so I'll give you a quick tour. On the left side, we have here the file manager. You can add files, add folders, you can upload files, and download all the source code. And of course, we will provide the source code for each question at the end of each section. You can also change the settings of REPL. You can have dark mode and you can increase the font size. We'll definitely be increasing the font size for our mobile students. Then here in the center, you have the file main.swift in this case, where you can type anything and it will print out to the console, which is on the right side. All you have to do is hit run, and there you go. You can see it being printed in the console. So as you can see, REPL is extremely useful. No downloading or installing of any software. All you need is this website. That is everything you need to know to get started. In the next lecture, we're going to jump into solving our first interview question with practical examples throughout the entire course. So don't forget to leave us a rating and review, and let's get started in the next lecture. Hello everyone, and welcome back to our Swift interview questions series. In this lecture, we're going to solve our first question together, and that is the question that is almost synonymous with interview question itself, Fizzbuzz. The Fizzbuzz question goes, print the numbers from 1 to 100, and for multiples of 3, print fizz instead of the number. And for the multiples of 5, print buzz instead of the number. So immediately we can think of the edge cases for this question, and that is, what if a number is a multiple of 3 and 5? Well, in that case, we would want to make sure that we print not fizz, not buzz, but Fizzbuzz. So let's go ahead and do just that. We'll open up a function that is going to solve this, and we can store it as a constant, and we're going to make a map that is going to store the fizz or the buzz or Fizzbuzz to print. And we can't forget that we also have to print the number itself, even if it is not a multiple of 3 or 5. So we'll call this Fizzbuzz, and we're going to put in an integer and return a string. And what we're going to do is go through the number in, and we are going to then open up a switch statement, and we will check if the number mod 3 is equal to 0 or the number mod 5 is equal to 0. In that case, it means we have a number that is divisible by 3 and 5. So we can go ahead and indent this a little bit. There you go, and close the switch statement. Now for the switch statement, we're going to have different cases. So if we have true for the first half and false for the second half, that means that the number is divisible by 3 but not by 5, so we're going to return fizz. Now the other case is if the number is not divisible by 3 but is divisible by 5, so we'll say case false comma true, and in that case we'll return buzz. Now we can also create a case for if the number is divisible by 3 and 5. So we'll say case true comma true, and we will return in this case Fizzbuzz. And finally, we should add a default case, and in that case we'll return the number itself. So the number will be printed to the console instead of fizz or buzz. So as you can see, we're using here a switch statement to check if a number is divisible by 3, 5, both, or none. And that is all that we need to solve the Fizzbuzz question. Now, of course, there are many ways to solve each question, so I encourage you to test out different ways of solving the question, and just make sure that this parentheses is not present. Otherwise, we'll be closing off the constant too early. Alright, so everything looks good, so let's go ahead and test this out now. We're going to use a print function, and we'll print an array from 1 to 100 just as the question asks, and we'll make a map containing that Fizzbuzz constant that we just created, and then we can join all the values with a separator of a comma, and just like that, this will print the result to the console. So let's go ahead and pull up the console here in REPL and hit run to see our result. And as you can see, we have being printed in the console 1 to 100, and at 3 we have fizz being printed instead of the number because 3 is divisible by 3. And same with 5, we have Buzz being printed instead of the number, because Buzz is divisible by 5 for the number being represented 5. And we can see that at 15 we have Fizzbuzz being printed, which is because 15 is a multiple of 3 and 5. All the way up to Buzz, which represents 100, because 100 is divisible by 5. So that means that we successfully solved this interview question. I do challenge you to try to find another solution, a different form of solving it, as well as taking the question one step further and challenging yourself to make it harder, such as, for example, accounting for more possible numbers that we want to print rather than just Fizz and Buzz, and taking it different steps further like that. So congratulations everyone on solving your first interview question. In the next lecture, we're going to be solving more questions looking at the most common categories you'll be asked about. Head on over to the next lecture. Hello everyone, and welcome back to our Swift interview questions course. In this lecture, we're going to solve the reverse words in a string interview question. This question goes: given an input string, reverse the string word by word. For example, if we had an input string reverse words in a string, we would expect the output strings A in words reverse. So what we will have to do in this case is find all of the spaces in the string and use that as our character at which we will break the string into an array of strings instead of an input string. And after we have that array, we can reverse the array to create a new string. So let's go ahead and do just that. Down here, we'll open up a function and we'll call this reverse words, and this function is going to take in a string, and it will also return a string, and that will be the reversed string. What we're going to do is make a function that is going to be a buffer string, because we have to use a buffer string to enable us to mutate a string. A string buffer is the same as a string, but it can be mutable. So let's go ahead and first we'll loop through all the characters to set this up. We'll say for character in the string. For each character, we'll check if the string at the current character is a space. Well, in that case, we're going to call our join buffer string function. And we have to create this function just above the for loop. And let's create that, join buffer string. What this function is going to do is it is going to create that mutable string for us. So first we're going to check if the buffer string dot is empty is not true. That means we need to add the strings together. So I'm going to assign a middle, and this will be new string dot is empty. If the string is empty, then we won't put in a middle, but if it has values, we'll put in a space. Then we'll take a new string variable and we'll assign it to equal a buffer string plus the middle plus the new string. This will allow us to reverse that string. And afterward, we will assign the buffer string to be empty again, that way we can reuse it. So let's go ahead and declare all the variables we just made just above the function. So we'll declare them. We need to declare a variable called new string, and this will be an empty string. As well, we need the buffer string. This will also be an empty string initially. Alright, so now that we have the join buffer string function set up, we can come back down here to our for loop where we're using that join buffer string. And if there's a space, that means we're going to create a new string from around the space. Otherwise, if the character is not a space, what we're going to do is take the buffer string and concatenate onto it the current character we're at. This way we can put in the character into our buffer string. And after we finish going through one word, we will then clear the buffer string and move on to the next word. Alright, after this for loop, we have to call join buffer string, and you'll recall that this function returns a string, so we have to return the new string, and the new string is the one that will be reversed. Let's go ahead and prove this algorithm by testing it out. We'll call reverse words and print out the string reverse words in a string. And if we pull up the console here in REPL and we hit run, then we will see that in the console will be printed strings A in words reverse. So that proves that we successfully solved this interview question. Congratulations on solving the reverse words in a string interview question. In the next lecture, we're going to be solving another question in our string/array section, so be sure to head on over there. Hello everyone, and welcome back to our Swift interview questions series. In this lecture, we're going to solve the isomorphic strings interview question, which goes given two strings A and B, determine if they are isomorphic. Two strings are isomorphic if all of the characters in A can be mapped to all of the characters in B. Now that is why we have in this example ABC. Each character only appears once in A and each character only appears once in B. Therefore, the strings are isomorphic. However, with AA, each character appears twice, whereas in AB, each character appears once. Therefore, these two strings are not isomorphic. In order to solve this, we can use a dictionary to keep track of the number of times a character appears in A versus B. And also what we can do is initially check the edge case that the strings are the same size. Because if two strings are different sizes, then they are immediately, in that case, not isomorphic. So let's go ahead and build out a function to do just that. We will make a function called isomorphic, and rather are isomorphic because they're two strings, and we'll put in string A as our first parameter and B as our second parameter, and we're returning a boolean because we're returning true if the strings are isomorphic and we're returning false if the strings are not isomorphic. First, we will guard that the A characters.count is equal to B characters.count. Otherwise, we will return false. So we're checking that the two strings are the same size. And what we'll do is we'll make a constant called A characters, and this will be a character array made of the A string. As well, we'll make a B characters array, and we're going to use this array later as well. Alright, so now we have accounted for that edge case, and whenever you solve these questions, you always want to think about the edge cases. What values could be null that you don't want to be null? What are values that you don't want to allow? And similar to that. So now that we have that accounted for, we are going to loop through all of the characters in the string. Starting at string A, we're going to go for character index from 0 to the end of A characters, so A characters.count. Let's go ahead and make sure we have all of the variables declared. Okay, we do. Perfect. And now we are going to make a constant in this case. And we're going to make a constant called A character. And this is going to represent the current character we're at. So we'll take A characters and we'll get the character index to get the current character. As well, we're going to compare it to B. So we have to store B character at the same index. So we're going to make a constant called B character. And this will be B characters at the current character index because we're going to compare the two. Next, we're going to check if A dictionary, which we'll make, at the A character, if that is equal to nil, and the B dictionary at the B character, if that is equal to nil as well, then we're going to move the two values. Let's declare these variables first. A dictionary and B dictionary. As mentioned at the beginning of this lecture, we're going to use dictionaries for this. So let's build those dictionaries up here. We're going to make a variable called A dictionary, and this is going to be a dictionary with the key of character and the value of character as well as the data types. And we're also going to do the same for a B dictionary. We're going to use a character as the key and a character as the value. So now that we have those declared, we can come back down here and use them. So we're checking to ensure, or first we're checking to see if at the current character we have a nil value. Then we're going to take the A dictionary at the A character, and we're going to assign that to the B character. And vice versa, we're going to take the B dictionary at the B character, and we're going to assign that to equal the A character. Otherwise, if we don't have nil values at both, we're going to check if the A dictionary at the A character is not equal to the B character. So that means that we have different characters there. Or, as well, we can check if the B dictionary at the B character is not equal to the A character. So we have mismatching values, which means we're returning false, because that means that the strings are not isomorphic. Now, if we loop through all of the characters in the strings and we never encounter this inequality, then we're going to return true, because that means that the strings passed all the tests at each character, and it means that we have isomorphic strings. So now we can go ahead and test out our solution. We can print down here, we'll print R isomorphic, and we'll check this on the strings like A, B, C, and D, E, F. We should get true for this. Now, I'm just going to check to make sure we have everything proper. Just make sure you fix any syntax errors. And for casting a string to a character, we just have to wrap the string name in parentheses. So once you have all of the code with us, pull up the console here and hit run. And as you can see, we have true being printed in the console because A, B, C, and D, E, F are isomorphic. But if we change the strings to be non-isomorphic, we'll have false in the console. So if I test it on A, B, B, and D, E, F, now I have false being printed. That is exactly what we expected, which means that we successfully solved this interview question. The time complexity for this question is going to be linear because we are looping through each character in the strings. That means the time complexity will be dependent directly on the number of characters in each string, and just one string because we're going through each character, comparing them. Congratulations on solving the isomorphic strings interview question. Thank you all for watching, and we will see you in the next lecture where we're going to continue on to a more advanced question in our array/string section. See you there. Hello everyone, and welcome back to our Swift interview questions series. In this lecture, we're going to solve the kth largest element in an array question, a very commonly asked question. The question goes, find the kth largest element in an unsorted array. That means that we have an array with a random order of elements, and our job is to find the kth largest element. And note that it is the kth largest element in the sorted order, not the kth distinct element. This is a constraint you will commonly also get with this question. For example, if we had an array of 3, 2, 1, 5, 6, 4, and k was equal to 5, that means we're looking for the fifth largest element, which would be 2. And if we had 3, 2, 3, 1, 2, 4, 5, 5, 6, and k was equal to 5, we're looking for the fifth largest element, which would be not 6, not 5, not 5, not 4, but 3. And you'll notice in this one, we're counting the two 5s as unique, distinct elements. We're not considering the two 5s to be equal just because they have the same value. All right, so to solve this question, well, because we are working with largest elements in this question, often that is a sign that you can use heaps in order to heap your elements from the largest to smallest. Now, this question can also be commonly asked as the kth smallest element, so that is a very similar question, just with a small twist in terms of the solution, because you have to find the kth smallest element. So you could use heaps. Of course, with every question there are many different ways you could do them, but you have to think about efficiency. So for efficiency, what we're going to do is use sorting instead. We will cover sorting later on in depth in this course, but of course there will be overlap between some of the sections. Now we can use sorting for this solution because we have an array, and the array is not sorted, but if we sorted this array, then we could take the element at the kth index and then account for zero-based indexing as well. But if we had it sorted, then it would be much simpler because we would just go up or down the array and stop at k. So that's exactly what we're going to do for the solution. Let's go ahead and open up a new function. We'll call this find kth largest, and we'll put in an array input of integers as our parameter, as well as k, which is an integer. So just as the question requires, we get an integer array and k and nothing else. And we need to return an int out of this function because we're returning the kth largest element. So what we're going to do is use a type of sorting that implements pivoting. So we will choose one of the elements in the array to be a pivot, and then we will sort all the elements around that pivot. And this will allow us to split the problem into subproblems. So instead of sorting the array all at once, we'll sort it in pieces. And this is for time complexity, and we will be going over this in depth later on as well. So let's go ahead and do just that. We're going to make an infinite while loop while true, and we will break out of this loop once the array is completely sorted. We're going to make a constant called pivot, and that will be the element we pivot around to sort all of the elements in the array in ascending order. We could also do descending order. It doesn't matter, but let's go ahead and call a partition function that we will make ourselves. So this partition function is going to help us sort the array. So let's build out that before we go any further. This will be another function that's just a helper function outside of find kth largest. It's going to be called partition, and this is a pretty standard function that is made whenever you sort something, an array typically. So we'll put into this partition function, we'll put in an array of integers, the same array we're working with, and we'll also put in a starting index. We'll call this from, and it will be an integer because it's an index. And as well, we need a to argument, and this is going to be the starting and the ending of the array. And this function is going to return an int. The int that it will return is the value we're pivoting around. So for this, let's go ahead and implement partitioning functionality. We're going to make a constant called pivot, and this will be the array at the from index. We're also going to make a starting index, and that will be from +1. As well, we're going to make an ending index, and this will be always 2. We're going to check while starting index is less than or equal to ending index. That means that we have a valid array that we need to sort. So while we have a valid array that we need to loop through, we're going to check if the array at the starting index is less than the pivot, and the array at the ending index is greater than the pivot. Then that means we have to perform a swap. And we're doing swapping in order to sort the array. So let's go ahead and build out a swapping function next, because that is our third helper function. This is again typical swapping functionality, part of typical sorting functionality. So let's add that next, and we will fill in these arguments and continue with our partition function after. But to understand swapping, let's do that next. We will add a swapping function, and we'll take in an array of integers, and we will go from an integer and to an integer, so we need all of those parameters as well. We're going to first make a constant storing a temporary value, and that will be the array from, and we will use typical sorting or swapping functionality in order to swap the value at the from index with the value at the to index. So I'm going to make an array, or I'm going to take the array at the from index and swap that value with the array at the to index. Then I'll take the array at the to index and assign that to equal the temporary value, which we had to use in order to store the from value, which was then changed. So that is all you need for swapping. We can come back up here and we can fill in those parameters with the required arguments for the swapping function. So for the swapping function, we're going to need to put in the array, as well as the starting index as the from value and the ending index as the to value. And remember, we're only swapping if we need to, which is why we have that condition there. Then we will take the starting index and increment it by 1. This way, we're going deeper into the array in order to check the swapping. And we'll also take the ending index and decrement it by 1. So doing the reverse, because the ending index is at the last value in the array. And then after that condition is set, what we'll do is check if the array at the starting index is greater than or equal to the pivot. And if so, we're going to take the starting index and increment it by 1. And this is going to ensure that we can go through all of the values up to the pivot. And as well, we're going to then check if the array at the ending index is less than or equal to the pivot. That means we have a valid value before the the pivot, and it means that we have to decrement the ending index by 1. And after this loop is performed, what we have to do is swap. We'll swap at the array from the from value to the ending index as the to value, and we'll return the ending index. And this is going to give us our partitioning here. Now that we have the partition function set up, we can come back up to the find kth largest function, and we can put in the required arguments. So as you can see, we're required to put in an array, and that array is going to be the same value that we had. So it's going to be the array that is input, and I'm just going to call this array, and I'm going to store our array input in that array. You can also use an in-out value. It's up to you, and it's also dependent on if the question requires you to save memory space or not. Alright, so we have the partition at the array. We also have to put in the from and to values. So we have to put in a starting index and an ending index, and I'm going to declare those values as well. So let's do that just down here. We have our array, which is the argument of the actual array. Then we need to also declare a starting index. Now, you can probably predict what this will be. It's going to be 0 because we're starting at the beginning of the array. Then we're also going to make an ending index variable, and you can also probably predict what this will be. It'll be the array, which we have array, dot count minus 1 due to zero-based indexing. So this is going to be the last value in the array up to the last value because we don't need to perform any swapping at the last value. Alright, so that is what we need to do in order to put in the parameters for the partition function. Then we can actually return our value. So remember, we're returning the kth largest. So that's where we get into finding the kth largest. Now that our entire array is swapped and sorted, we have fixed that. We have manipulated the array, so now we have a sorted array. Now all we have to do is find the kth index. So what we're going to do is check if the pivot plus 1 equals k. If that's the case, then we'll just return the array at the pivot, because that means that we happened to choose a pivot that was exactly equal to k. So this is just one of the edge cases that if we happen to have this condition, that means that we lucked out and we don't have to perform any checking for k. Otherwise, we'll add an else if. We'll check if the pivot plus 1 is less than k. What we'll do is take the starting index and assign it to equal the pivot plus 1. And otherwise, we'll also check if the pivot plus 1 is greater than k. Then we're going to check the ending index and assign it to the pivot minus 1. This will also be the case if the pivot plus 1 is greater than k, but if it's equal to k, it'll just pass this condition up here. And that is all that we need in order to find the kth largest value. And as you can see, it's going to decrement down, and then eventually it will return out. So it's going to keep looping and keep partitioning, and then finally it will return out once we've found a k. Alright, so let's go ahead and test out our solution. That is all that we need for this algorithm, so let's test it. I'm going to come down here and call print. I'm going to call find kth largest, and I'm going to put in an array, so I can put in, well, let's see, I can put in the same values we had at the beginning because we're familiar with them. So I'll take this array here and I'll put in that array exactly, and then I'll put in 5 as k. So we're looking for the 5th largest element in the array, and I'll hit run. And as you can see in the console, we have 2 being printed, which is exactly what we expected. We can also test this on another value, such as this array, the second array, and again k equals 5. And we can test that second array. It's always a good idea to test on multiple arrays. And we have 3 being printed, which is again exactly what we expected. That means that our functionality is running perfectly. Okay, of course there can always be optimizations, but we have a solution which is time efficient, and time efficient enough because if you have large input sizes, then you need to build and a solution that is efficient enough for that large of an input size. If your algorithm runs too slowly on a huge input size, such as an array of 1,000,000 elements, well then you could fail the test because your algorithm, although it works, it's too slow. But if it's fast enough, then you will pass that question. Alright, so congratulations everyone on solving the kth largest element in an array interview question. Quite a popular one, commonly asked, so I'm glad we could cover it. In the next lecture, we're going to be starting a new section of our top 10 most commonly asked about sections on the coding interview. See you in the next section. Hello everyone, and welcome back to our Swift interview questions series. In this lecture, we're going to solve the set matrix zeros interview question, which goes, given a 2D matrix, if an element is 0, set its entire row and column to 0. Do it in place. So there are two parts to this question. First, we have to look for elements that are 0, and if we find one, we have to set the entire row and entire column to 0. The second half of this question is that we must do it in place, which is a constraint. That means that we cannot create any new matrix. We cannot use up more space in memory. We must manipulate the existing matrix. So this puts a constraint on the kind of solutions you can build. And the reason for that is to save memory. So in order to solve this, what we can do is use a nested for loop to go through all of the rows and all of the columns, and we can check for zeros. We can first check at the top row and at the first column, and then we can check all the other values as well. So because we're working with matrices, there will be at least quadratic time complexity because we have to go through all of the elements. So it is valuable to think about how you could improve this, because when working with matrices, because you have this table, there can be quite a large time complexity. So let's go ahead and look at just that. We're going to open up a new function. We'll call this set zeros, and this is going to take in a matrix. Now it has to be an in-out parameter because we have to work with the existing matrix. We can't copy it to add more space in memory. And I'm going to put in a two-dimensional array of integers, just as the question began with. And what we're going to do is go through all of the rows. So for row in matrix.indices, this will return all the indices of the matrix. It will return the row count specifically, and we're going through all of the rows. And what we'll check is if the matrix at the current row and at the 0th column, if it's equal to 0, that means that we have found a column with a 0. So we have to say is call with 0 equal to true. And we will declare that variable up here. We'll call this is call with 0, or even just call with 0, because for variable names typically you want to use nouns, not verbs. You want to avoid verbs in your variable names. So we'll initially assign it to false, but if we find a 0 at the 0th column, then we'll assign our call with 0 variable, our column with 0 variable, to equal true, because we found a 0. What we'll do after that is go through all the columns beginning at 1 and ending at the number of columns. Now to get the number of columns, you call matrix at the 0th row dot count, and that will return the number of columns in that first row. And that will typically be equal to the number of columns in every row. And let's check if the matrix at the current row and at the current column is equal to 0. That means that we found another 0 in a column that is outside of the 0th column. And if we found another 0, we'll take the matrix at the current row and at the 0th column, and we'll assign it equal to 0. We'll also take the matrix at the 0th row and at the current column and equal its assignment to 0. So that is going to go through all of the rows. And now let's go ahead and go through all of the rows up to the count. So we'll do that down here in another for loop. What we're going to do is take for row beginning at 1 up to matrix.count. We'll then go through all of the columns in the matrix as well with a nested for loop. And what we'll do in this nested for loop is we'll check if the matrix at the current row and at the 0th column is equal to 0, or if the matrix at the 0th row and at the current column is equal to 0. And if so, that means that we have found a 0. So we have to take the matrix at the row and column and assign it to 0 as well, because that means that the associated row and column with that value contains a 0. So we must match its value to become a 0 as well. So now that we have performed that, we're going to come down here and we'll check if the matrix at the 0th row and the 0th column is equal to 0. Then we're going to go through all of the columns in the matrix. And what we'll do is we'll take the matrix at the 0th row and assign it to equal the 0 as well at each column. And this is another check that we have to perform, because that is that topmost, leftmost value. We'll also check at the end if call with 0, that variable that we declared up here, if that is equal to true, and we don't have to check the equal to true part, that is just assumed, then if call with 0 is true, what we're going to do is take the row, so take each row up to all the rows, and we'll take the matrix at that current row at the 0th column and put all of the values at that 0th column to equal 0. And that is all that you need in order to set the matrix zeros. So as you can see, there are quite a few conditions you have to test for and quite a few loops you have to do to go through the matrix, but that is it. So now that we have that, let's go ahead and test out our solution. So I'm going to come back up to the top and I'm going to copy this matrix that we have and come back down to the end of the file and make a variable called array and put in that array that we have as the initialization. Then I'm going to go ahead and call our set zeros function on the array. So I'll call it set zeros, and I have to put in the array as an in-out value. I'm also going to print the array, and for that we're going to need a helper function. So let's quickly add a helper function called print array. This will allow us to test out our functionality. So I'll call this print array, and we're putting in a matrix, a two-dimensional array, also known as a matrix, and we're going to go through all the rows up to the count, which will be the number of rows, and then we'll also go through all of the columns in all the rows. So we'll go through each value in the matrix and we'll print the current value. Let's also add in a space in between each value. And then afterwards we can also add a print statement. That way we will have a space between each row after we have gone through the columns in a certain row. We will print a new line break. This is for readability in our testing. So let's go ahead and come back down and pull up the console and hit run. And as you can see, we have a new matrix being printed in the console. The input matrix had 1 0, but the output matrix has the row with the 0 and the column with the 0 being changed to contain zeros as well. That is exactly what the question asked, which means that we successfully solved this interview question. Now the time complexity for this solution is going to be O of the number of rows times the number of columns, because we're going through all of the elements in a multiplication-like table. The space complexity is O of 1, so constant space, because we're not using any extra space. We didn't make a new matrix, we just manipulated the existing matrix. And this is a key difference to understand with the questions you answer. With some questions you may make more variables which will take up space in memory. But if a question asks you specifically to do it in place, that means you must work with the existing argument. You cannot create a new matrix in memory. Congratulations everyone on solving the set matrix zeros interview question. In the next lecture, we're going to continue on with this popular section commonly asked about on the test is the matrix data structure. So we will look at more questions coming up, discussing how we can solve more questions regarding the matrix data structure and build algorithms for the matrix data structure. Thank you all for watching, and head on over to the next lecture. Hello everyone, and welcome back to our Swift interview questions series. In this lecture, we're going to solve the commonly asked spiral matrix interview question. The question goes, given a 2D matrix, return all elements of the matrix in spiral order. Spiral order is a specific order, which means that we have to print all of the values at the top row first, then we go down the last column, then we go across the bottom row backwards and backwards up the first column. And then we continue this pattern as we go deeper and deeper into the matrix until we have no more values left. That's why for this example, we are printing 1, 2, 3, 4, then 8, 12, 16, which is that last column, and then 15, 14, 13, followed by 9, 5, and then we go deeper into the matrix. And as you can see, there is no overlap. We never print a value twice. So in order to solve this interview question, what we can do is go through the pattern over and over again, but at the end of each loop of the pattern, we will cut off the outer border of the matrix. That way we have a starting matrix, then we cut off the outer layer and we go deeper into the matrix, and we can do that over and over again until we have no more values left. And this will allow us to work with the matrix, the entire matrix, and chop off its borders. So let's go ahead and do exactly that. We'll come down here and we'll open up a new function called, let's see, print spiral matrix. And we're going to put in a matrix. It's going to be a two-dimensional array. And we're returning a one-dimensional array because we're returning all the values. We're returning all the values of the two-dimensional array printed as a one-dimensional array. And what we're going to do in this case is we just have to return an int array outside of the actual parameter calls. So let's go ahead and open up that function. And first we're going to check the edge case. The edge case is going to be if the matrix has no more values left. Well, in that case, we can go ahead and exit out of our loop. And we can also consider that an edge case because if someone tried to input an empty matrix, we have to account for that extraneous value. So I'm going to make a variable called the result, and this is going to be the result one-dimensional array, and this is going to be a one-dimensional integer array. Initially we can assign it to an empty array, and we're going to check if the matrix that we're given, if its size is 0, and that means it has no values, we're going to just return the result, which will be empty initially. However, if it does have values, if the matrix we're given has values, and if we still contain values, we need to print for it in spiral order, that's where we have to go ahead and build out that pattern. So we're going to build out the spiral pattern, which is the top row, then the right column, then the bottom row, and the top column, the front column. So let's go ahead and build that out exactly. Let's make variables for this. We'll make a first row, which will be 0, because that is the first row we need to print for the spiral matrix. After the first row, we're going to print out the first or last column rather. And the last column is going to be initially the matrix at the 0th index dot count -1 due to zero-based indexing. So this will be the number of columns there. After we print the last column, we need to print the last row, but in reverse order, which we will account for. And after we have printed the last row, we're going to print the first column as per the rules of spiral order. And initially that will be 0. So now that we have all of our variables declared, we can go ahead and use them. We'll use them in order to go through the spiral pattern. So first step in the spiral pattern is to check while the first row is less than or equal to the last row, and the last column is less than or equal to the last column. I meant the first column here. While the first column is less than or equal to the last column. Well, this is checking to ensure that we still have values left in the matrix. We actually have a matrix we need to print out because we have valid values for the row index and the column index. If we have valid values, what we're going to do is go through each column. So for column in the first column up to the last column, what we'll do is take the result and append onto it the matrix at the first row and at the current column. And after that, we are going to go ahead and go through the row. We're going to make a variable called current row, and this will be the first row plus 1. And we're going to check while current row is less than or equal to last row. We'll take the result and we'll append to it the matrix at the current row and at the last column. This is step 2 of our printing. First we printed that first row, which is up here. Now we're printing the last column. just as the pattern requires. And we also have to remember to increment the current row plus by 1, because that way we can move further along deeper into the matrix. So after we have gone through that last column, we're going to perform another check to continue on through our pattern. We're going to check if the first row is less than the last row and the first column is less than the last column still. Then we're going to now print the bottom row in reverse. So we'll need a variable for the current column, and this will be the last column minus 1 because it'll be the index of the current column, so we have to account for zero-based indexing. And we'll check while the current column is greater than the first column. So we have to ensure that we have 2 columns present, otherwise we would not have a 2-dimensional array anymore. So we're checking to ensure that we have different columns. And if so, then we're going to take the result and append onto it the matrix at the last row and at the current column. So this is going to print out all of the values in that last row, but in reverse. And we're going to decrement the current column each time, because that will allow us to go through all of them in reverse, because we're decrementing instead of incrementing. And finally, the last step in the pattern is to print out the first column backwards. So we're going up the leftmost column. So we're going to make another variable for that called current row, and this is now going to be equal to the last row, because we want to start at the bottom, because remember we're going in reverse order up the first column, which means we have to start at that last value, which is the last row in that column. And we're going to check while the current row is greater than the first row. That means that we have valid values in the column to print. And while that is true, we're going to take our result and append to it the matrix value at the current row and at the first column. So this is going to go through all of the values in the first row. So we also, in the first column rather. So we also have to take the current row and decrement it by 1. That way we're starting at the last row in that first column and we're going up the rows. And once we hit 0, then we will stop. Because actually once we hit 1, because we already printed that first row, remember? So we cannot print that first row again. Alright, so that is going to be the pattern there. Now, outside of this while loop that we have, which is ensuring that we have a matrix present, we have to add more functionality. So that is going to be just before the function ends. We need to go ahead and add more functionality. So now that we have printed all of the values in the first row, then the last column, then the last row, and the first column, we have to go ahead and subtract those borders. We have to cut the matrix, cut off its crust, if you will. And to do that, we're going to take the first row and increment it by 1. So we have a new first row for the matrix. Instead of the first row is now being moved to the second row and deeper into the matrix until we were breaking out of the matrix. Similarly, we have to take the last column and we have to decrement it by 1 because we have to chop off that last column. And then the last row, we have to also decrement it by 1 to go and chop it off. Our new last row is going to be the second to last row. And we also have to take our first column and increment it by 1 because we have to take that left row and shift it over because we don't want to go through the border twice. We want to go deeper into the matrix. And then, let's see, after we have performed that, what we want to do next is return our results. So what we need to return is just going to be that value that we made, which is going to be the result. So we're going to return the result. And just like that, we have all that we need in order to solve this spiral matrix interview question. Let's go ahead and come back to the top and copy this two-dimensional array, this matrix. Then we'll come back down and we're going to use that two-dimensional matrix. We'll call this matrix and we'll copy in those values because we are familiar with those values, so we know what we expect when we print this matrix in spiral order. So I'm going to take our function called print in spiral order, and I'm going to go ahead and put in that matrix into the parameters of the print spiral matrix function. After this, I can go ahead and pull up the console and hit run. Now it looks like we are missing a parentheses. Yes, okay, so we have this if statement, and we just want to make sure that we move this bracket outside of here, because this check that we have up here is checking to ensure that we have all of the values valid, and we need that for this portion as well. And after that, we can go ahead and move this loop just like that. Okay, and we're getting an error, cannot assign to immutable expression of type int.type. So let's go ahead and fix that as well. So in order to fix this, all we have to do is change that equal sign to a colon, a simple syntax error. Let's hit run again, and as you can see now, we have being printed in the console 1, 2, 3, 4. That is the top values, the first row. Then we have being printed 8, 12, 16, which is that last column. Then 15, 14, 13, exactly as we expected. That is that last row backwards. Then 9, 5, which is the first column upwards. 6, 7, 11, 10. So that is exactly what we expected. We have the matrix being printed in spiral order, which means we successfully solved this interview question. Congratulations, everyone. Let's talk about the time complexity. Well, let's see. Because we're using these nested for loops, because we have nested for loops, that means that we have time complexity that is O of the number of rows times the number of columns. Now, we're using a while loop and then a for loop inside of the while loop. And yes, we're going through all of the values. So because we have to reach all of the values in the matrix, we have to go through all of them. That means that the time complexity will be O of the number of rows times the number of columns, which will give us all of the elements input. Thank you all for watching. Congratulations on solving another interview question. In the next lecture, we're going to solve another question in our matrix section. So be sure to head on over there. Hello everyone, and welcome back to our Swift interview questions series. In this lecture, we're going to solve the number of islands interview question. The question goes, given a 2D grid map of 1s, which represent land, and 0s, which represent water, count the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all 4 edges of the grid are surrounded by water. So as you can see, we have here in our input, we have a 2D grid, and we have 4 different areas where we have 1s connected horizontally or vertically. Therefore, we have 4 islands, and we have an output of 4. Sometimes you may also get the constraint that land can be connected diagonally, in which case we would only have an output of 2. So that is another variation on this question to consider. So in order to solve this question, well, we have a grid, so we'll have to go through all of the rows and columns in the grid. And what we can do is use depth first search in order to look for connected land. So depth first search is a type of search where it is more aggressive in that you search for the deepest possible path you can find, and once you reach the end, then you come back up and you go and find the next deepest path. And in our case, deepest paths mean the islands. So we'll take one element and then we'll search for all of its deepest neighbors that are also land. And therefore we'll find lands by looking at the neighbors. So let's go ahead and build this out as the best way of understanding this. We'll make a function called find number of islands, and this will put in a grid input. It's going to be a 2-dimensional integer array, and we'll return an int, and the int that we're returning is going to be the int representing the number of islands. And first, let's account for the edge case. So first we'll check to ensure that we actually have rows and columns in our grid. We want to ensure that we have a valid matrix. So we'll guard that the grid input .count is greater than 0 and that the grid input at 0, so the number of columns is also greater than 0. We need that to be true, otherwise what we're going to do is not allow the number of islands search to be performed. So we'll guard that, else we will return 0 as the number of islands. So we have our edge case checked. Now we can go ahead and we'll go through all of the rows and columns. So I'm going to make a constant called rows, and this will be grid.count, the number of rows. I'm also going to make a constant called calls, and this will be the number of columns using the syntax grid at the 0th row.count. This will be the number of elements in the 0th row. So what I'm going to do is I'm going to loop through all of the rows from 0 up to the last value, and also I'm going to loop through all of the columns. This way we will reach all of the values in the grid. And what I'm going to do is check for land. So I'll check if the grid at the current row and at the current column, if that value is equal to 1, that means we have found land. So what we're going to do is increase, first of all, our count, which is our number of islands. So I'm going to call this number of islands. And I'm going to declare that as a variable up here. It will be a variable called number of islands, and initially it's going to be 0. But as soon as we find a 1 value, that means we have land. And in that case, I'm going to call depth first search, and I'm going to put in the grid that we have, which I also need to save as a value. So I'm going to save the grid. Let's see. We currently don't have the grid saved, so let's add that as the first value, or the second value rather. Below our guard statement, we can make a variable called grid, and that's just to save our grid input because it's not an in-out value. Okay, so we'll call depth first search, which is another function we'll have to build out, and we're going to put in the grid as well as the number of rows and columns and the current row and column, and you'll see exactly why we need those shortly. So we're going to implement this method, and it's going to find all of the neighbors for us that are also land, because if we can find a neighbor that is a land, then that means that we have an island. Otherwise, this is just an island of 1. So let's go ahead and return the number of islands after we have traversed through all of the rows and columns. That is all that we need for this function, our find number of islands function. We have to implement the depth first search function next. So I'm going to go ahead and call it depth first search, and we're going to put in a grid, and this will be an in-out variable this time to work with those and save space. And I'm also going to put in the number of rows, also an int, as well as the number of columns, also an int, the current row, which is an int, and the current column as an int. And these are all of the parameters we need in order to perform depth first search. So first I will perform a guard statement. So I have to check the edge cases. You always want to check the edge cases. We want to ensure that the row is greater than or equal to 0, and that the current row index is less than the number of rows. As well, the same exact thing for the columns. It has to be the column index of a positive number or 0, and also the column index must be less than the number of columns. As well, we want to check if the grid at the current row and the current column is equal to 1. We want to guard that, otherwise we're going to return out of our search. Alright, and now that we have that guard, that edge case checked for, we're going to use recursion. So I'm going to first initialize the grid at the current row and column. I'm going to initialize it to 0, or assign its value to 0. Then I'm going to call depth first search recursively on the neighbors. So I'm going to put in the grid of the rows and the columns, but this time on the neighboring row at the current column. And similarly, I'm going to call depth first search again on the grid, put in the rows and the columns, which is the entire grid, and this time look at the neighboring row at the same column. And I'm going to do the exact same thing for the neighboring columns. So I'm going to put in the rows and the columns, put in the same row, but put in the value at the next column. And similarly, we have to perform depth first search on the rows and the columns at the current row, but at the previous column. And why? Well, because this will allow us to find all of the connected islands, because we're looking at all the neighbors. And just like that, that is all we need in order to implement depth first search, which means that we can now use our printing to perform a check. We can check that we built a successful algorithm. I'm going to copy the exact island we had at the beginning of the lecture, the exact grid specifically that we had, I'm going to make a matrix variable to store that grid. So this is the grid we're working with, and we're looking for the number of islands. So all we have to do is call our find number of islands function on this exact matrix. And we know that we're expecting an output of 4 if we do not count diagonals as neighbors. So I'm going to call print so that we can see the value in the console. I'm going to call find number of islands, and this function requires just one argument, a matrix. Now that we have that, I'm going to pull up the console and hit run. And it looks like we're just missing a space at line 46. So we'll fix that. There you go. Just make sure you fix any syntax errors. And once you have, then you'll see that when you hit run, you will have 4 being printed in the console. That is exactly what we expected because there are 4 islands in this matrix, in this grid, because we did not consider diagonals to be connected. Now you can include more neighbors in your depth first search check, and that is going to account for the diagonal neighbors. Otherwise, each of these islands is considered unique, and especially this one at the top, because it is surrounded obviously by water. So congratulations everyone on solving the number of islands interview question. This one is commonly asked. You may also see it as the number of countries or different continents, but however it is worded, there is a common pattern with this type of question where you have to look through the neighbors of a grid by using search, specifically depth first search in our solution. So congratulations everyone on solving a popular interview question. Thank you all for watching. Congratulations on solving another interview question. We will see you in the next lecture where we're starting a new section. Again, we're continuing on with our top 10 most popular categories asked at the interview test. So be sure to head on over to the next lecture where we're going to be starting a brand new section. See you there.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only do we get the access to this course, but you'll get access to a lot of other courses in a huge bundle, and it's on sale today. So buy before the sale ends. Thanks for watching, and I'll see you in another video.